Well, hello and welcome, everybody. Hey, this is a walkthrough of a paper 2 from IB Math Standard Level. So if you're in that kind of class and you got your test coming up, this is a great resource for you. We're going to go through every single one, and we're not just going to talk about the problem. We're also going to talk about some of the background information so that you can also answer other questions that are similar so you can really get ready for this year's test, all right? So they're 90-minute tests. You can use a fancy calculator like a Ti-Nspire. I'm going to show you some things you're going to do on that calculator here in this review. And of course, you're going to use a pen, and you got to bring your championship attitude. Now, there are 5 questions on this test. 90 minutes, 5 questions. So first one's data, Spearman rank, coefficient, right? Second one, you've got some geometry, some trigonometry, some modeling with sinusoidal functions. And that one looks kind of scary, but it's actually not too bad. Third one, you got some interest, some financial applications. You're going to use the Financial Solver app, and most likely you're going to end up having to do some logarithms to solve one of those questions. The fourth question is the tricky one, I think. You've got normal distribution, chi-square, goodness of fit test, and some hypothesis testing. But the reason number 4 is particularly tricky is the other questions. They usually kind of guide you to what to do without telling you specifically, hey, do this. Number 4, you got some stuff to figure out that you have to do in order to answer the question. And number 5, you got some calculus. You got a derivative using the power rule, and you're going to use the trapezoid rule, and you've got some integration to do. So the timestamps you can see here, so you can navigate from one question to the next. But even if you get them right, don't take it for granted. Make sure you're really being thorough and not letting anything slip. Make sure you understand everything about every single problem that you possibly can. Chase it all down. Don't let anything slide by, because the way it works is if there's something you don't understand, Murphy's Law, that thing's just going to come up and bite you when it matters the most, which would be on test day. You put a lot of work into this class. Let's make sure we get a good result. Let's do our part, right? Okay, let's dive into problem number 1. All right, so as part of his mathematics exploration about classic books, Jason investigated the time taken by students in his school to read the book Old Man and the Sea. He collected his data by stopping and asking students in the school corridor until he reached his target of 10 students from each, that's bold, of the literature classes in his school. All right, make sure you read this very carefully every single time. The information they give you, those are the clues you have to use to answer the question. So start there. All right, now state which of the 2 sampling methods, systematic or quota, Jason has used. Well, that's not so bad. They kind of narrow it down. We got a 50-50 chance, right? Now, this is the types of sampling that you're supposed to know. We have 2 of them here. We have systematic, which means you basically set a rule that you use to collect your data. The other one is quota. Now, quota, you're only picking from people that fit within a certain category. And from there, though, you can just use convenience, like, picking people from a certain class. And the convenience part of it is they just happen to be walking down the hallway when you're there. So quota is definitely it between those 2. So just write down quota, you're good to go. Now, part B. Write down the median value or the median time to read the book. So it says Jason constructed the following box and whisker diagram to show the number of hours the students in the sample took to read his book. And I just violated my rule saying to read this before you read the question. Man, I just didn't see it up there. But make sure you read it first. All right. Now, interquartile range and box and whisker plots, they work like this. The line you see right here is the median. That's the second quartile. This is the first quartile right here, and this is the third quartile there. Maximum and minimum. 50% of the data is in here, 25 over here on the right, 25 over here on the left, and we're going to be dealing with outliers here in just a moment as well. So the median is right there. It is exactly 10 hours. So you just write down 10 hours, good to go. Now calculate the interquartile range. So this is worth 2 points. So that means you better write something down. You've got a formula in your formula booklet that you can use. Q3 minus Q1, that's the interquartile range. So to get your points, start there, right? So Q1's right there, Q3's there. We're going to find those 2 values and subtract them. Q3 is really easy. That's 15. But Q1, we got to do a little counting. Turns out each 2 points is worth 1. Right? Because if you counted all the way through, you'd end up past 10. So each one line is worth a half, so 2 points is worth 1. So that's from 7 to 15. So the interquartile range, this is exactly what you're going to write down to make sure you get your 2 points, right? All right. So next up, Mackenzie, a member of the sample, took 25 hours to read the novel. Jason believes Mackenzie's time is not an outlier. All right. So now I set it up so I couldn't mess up and violate my own rule. I had to read the context before the question because now there's the question. So determine whether Jason is correct. Support your reasoning. 4 points. That's a lot. All right. So first thing first, an outlier. Well, the way that works is if it's 1.5 times of the interquartile range past either the third quartile or before the first quartile, then it's called an outlier. So the way that works is like this. You take your interquartile range and you multiply by 1.5, right? So let's talk about the side to the right because that's what we're most interested in. 1.5 times the interquartile range plus Q3. So starting here and adding that, right? Let's see what that is. 1.5 times 8 is 12. 12 plus 15 is 27. So 27 would be the upper bound. That's like that's where the outliers begin. 27, that would be an outlier. So 25 is less than that. So, yep, no worries. Now on the other side, for other instances, right? We don't have to worry about it here, but the smaller outlier would be 1.5 times the interquartile range to the left of 7. So you'd start at 7 and subtract that value. So that'd be a negative time. That doesn't even make sense, right? So to get your 4 points right here, that's a lot of points. Make sure you write down your formula. I do not believe that the formula for outliers is in your booklet, so you got to remember it, right? So you write down your formula, you plug in your numbers, and then you show that the value is less than the outlier, and then you state your reason, right? Support your reasoning. 4 points is a lot, so don't be lazy here and just write this down. You will probably get 1 point if you're lucky if you only wrote that down. All right? So next up. All right. So for each student interview, Jason recorded the time taken to read Old Man and the Sea, and that's X time, measured in hours, and paired this with their percentage score on the final exam, Y. So here's the score on the test. These data are represented in the scatter plot. All right. Describe the correlation. Well, if you draw a line of best fit, which kind of averages all those points, you can see it's got a negative slope, so the correlation could be described best as negative. Next part. Jason correctly calculates the equation of the line of regression of y on x for these students to be y equals negative 1.54x plus 98.8. He uses the equation to estimate the percentage score in the final exam for a student who took 1.5 hours. Find the percentage score calculated by Jason. All right, now this is worth more than 1 point again, so you better write something down. Yes, all you're going to do is plug that number in, 1.5. You're going to replace x with it, so write it down on the paper because it's worth 2 points. Write down your unrounded answer before your rounded answer. We're rounding to 3 significant figures unless contextually it makes sense not to, or if the instructions say otherwise. All right, so that's it right there. We're going to get our 2 points for that. Now, Jason, let's see, that part's the same. He uses, yep, that part's the same. So state whether it's valid to use the regression line y on x for Jason's estimate for this student. Give a reason for your answer. All right, that's worth 2 points. So let's look at 1.5 hours. That's going to be way over there somewhere. Nope. We don't have any data over here. So it's not valid. Because 1.5 does not lie with any of the recorded data points, it's maybe it's even an outlier. I don't know. But anyway, it's way over here. I said it's an outlier there, but I'm actually not sure it's an outlier. But we can't say, in fact, I'm going to scratch that out. It is not an outlier because we looked at what the outliers were earlier, assuming this is exactly the same data, right? But there are no data points over here, so we know for sure that it's not valid, because we don't really know what happens to the left of there. We've got no data to represent or to kind of give us an estimate, so it's not valid. All right, next up, we're going to be doing some calculator work here in just a second. We've got a 2-point question. Let's go ahead and read the context. Jason found a website that rated the top 50 classic books. He randomly chose 8 of these classic books and recorded the number of pages. For example, book H right here is rated 44th. There's our rating, and has 281 pages. These data are shown in the table below. So they walk you through this so you don't have any sort of confusion about how this is all put together. So take your time and read this. If you take your time here, doing the math goes way faster. All right? Now it says Jason intends to analyze the data using the Spearman's rank correlation coefficient. Wow. Can you say that cleanly? I'm surprised I did. All right, R sub S. All right, so copy and complete the information in the following table. Okay, so we're doing a rank. And in case you're not sure, they give us a start. We're going from largest to smallest for the number of pages. And the reason I know that is A, 4,215 pages. It's a really big book. Is the most pages, and we said that's number one. So we're starting with number one being the largest. So we can go ahead and scratch that one out of there. We know that's good. Now the next largest looks like it's 1225 right there. So that would be D. So book 2 is D. The next one would be 863. Right? So that's 3, and then 624 and 4, and from there you kind of see how it goes. Now, the bottom is pretty handy. It's pretty nice. It's already set up for us, but don't get complacent. It doesn't have to go this way. It just turns out that this one's already in order from smallest to largest, and A being 1, and then 2, and then the third smallest is 5. Do you see? So all nice and done. All right, next up, calculate the value of R sub S, and we're going to have to do some calculator work, right? And then it says to interpret your results. So that's worth 3 total points right here. All right, so here's our spreadsheet right here, right? And here's the steps you're going to do. You're going to open a spreadsheet, and then you're going to enter each of these columns, and you have to make sure you name those columns. And then we're going to do statistics, stat calculation, 2 variable statistics, right? And then we have to use the drop-down menu and, find the 2 columns we named, and then see how it goes. So right now you can just see the screen. Unfortunately, if I zoom out too much further, you can't see the display. So I'm going to have to move back and forth right here for so you can see this. So basically, when you turn on your calculator, you go home, right? And then you click on the spreadsheet like that. You open up a new spreadsheet. Now, I had just entered all of this data right here. So I said N was the number of books or the number of pages, and R was their top 50 rating. And I just entered the numbers from the data right there, right? So from our chart. 135 here. Let me squish this down just a little bit, and then I'll show you. There we go. So 135, 2, 6, 7, 8, and 4, right? And 7 is the last one, right? All right. So now let me show you how to go ahead and run the test. I already have an example of it over there on the right, but hit menu, right? And then statistics. And then this one's stat calculations and 2 variable statistics. All right, so now here, don't type it in. Click the button and then go down and find the name. So N, I had called the first column for the number, and then the next one I had called R. So go through like that. Oops, click R. And then for the Spearman test, you don't have to do anything else. You just hit OK, and it asked me if I wanted to rewrite mine. We had to find, and I said yes, of course. So we have to go down. We have to find the R value. There it is, 0.714286. So make sure you go ahead and write down that entire thing. Okay, so there we go. Got all that done. So that was our number. We rounded it. Now interpret the result. This next part right here, I think you got to know. 0.7 is the threshold from weak to moderate positive correlation, and 0.7 and higher to 1 is a strong positive correlation. We have 0.71, so we're a little above that. So we would say, when we interpret it, we could say that there exists a strong positive correlation between the number of pages and the top 50 ranking. Use the verbiage, use the descriptions that they used in the problem, right? Okay, so now problem number 2. All right, this is worth 17 points. This one's kind of ugly looking. It's really not all that bad. All right. Now, the diagram shows a circular clock face with center O. I love how the British don't know how to spell. The clock's minute hand has a length of 10 centimeters. All right. And the hour hand is 6 centimeters. At 4 p.m., the endpoint of the minute hand is at point A, and the endpoint of the hour hand is at point B. All right. And then it says, find the size of angle AOB. This is how they write it, with the vertex being the center with a little hat on top. And it says in degrees. And once again, it's worth 2 points. So that means you better show some work. Now, here's the idea. The hour hand is what has been moving from 12 here, and there's 12 hours in a full rotation. So a full rotation is 360 degrees. So 12 hours is worth 360 degrees. Now we have 4 of the 12, so 4 over 12 equals our angle over 360. Don't know what that is. Going to multiply both sides by 360. Simplify, 120 degrees. That's x. All right, so first one's down. Pretty good. Part B, find the distance between point A and point B. So we know that's 120 degrees. We're going to use that to figure out the next part. So from 6 to 10, like that, that's going to be the cosine rule. 3 points right here. So write down your formula. It's in the formula booklet. This right here, this is an acronym that I use in my class. You have to be there to get it, but that's our formula. So write down the formula just like it is before you plug in any numbers. It's worth the time. It doesn't take that long, and it keeps you nice and structured and keeps you from making silly mistakes. So then we plug in our values, and then we use our calculator. We're going to find it's equal to 14. All right. Now, between 4 o'clock and 4:13, the endpoint of the minute hand has rotated by angle theta from point A to point C. And it's illustrated in the diagram below. So find the size of angle theta in degrees. Once again, this is worth 2 points. I'm going to hit this every single time. If it's worth more than 1 point, you better write something down. If you're my student and you make a silly mistake and you lose all the points because you didn't write something down, you know you're going to have to answer to me. Anyway, 60 minutes. We're talking about the minute hand now. So 60 minutes is a full rotation. So 60 minutes is going to be related to 360 degrees. We have 13 of the 60. So 13 over 60 is equal to the angle theta. I wrote x, but the angle theta over 360. So we're going to multiply both sides by 360, and 78 degrees is what we got. All right. So I know that's 78 degrees right there. Okay. So next up, calculate the arc length AC. So that's AC. All right, that's again worth 2 points, so you better show some work. Now, arc length is just part of the circumference. Just like 78 degrees is part of the rotation. It's not the full thing. The circumference is all the way around. That's 2 pi r. The rotation all the way around is 360 degrees. We have 78 degrees out of 360. So this is the formula for circumference, 2 pi r. That is the formula. You better know it. You got to know it. Even if it's in the reference sheet, there's some things you just have to know, because when you're doing like an arc length or a sector area, there's a concept at play that you really got to have your head around, and knowing that formula is part of it. So anyway, we have a portion 78 degrees out of 360 of the whole thing. So 78 over 360 times 2 pi r. Putting that all in the calculator, 13.6 centimeters. Don't forget your unit. All right, next up, part E, calculate the area of the shaded sector AOC. Well, it's almost the same question, except instead of asking about a length, we're asked about an area. So pi r squared is the full circle. That's for the 360 degrees of the whole kit and caboodle, but we only have 78. So we have 78 out of 360 pi r squared. Write down the unrounded before the rounded. Round to 3 significant figures unless it says to otherwise. Boom. Make sure you got your unit there. Good to go. All right. Now, a second clock, I think it should say an additional clock or another clock, is illustrated in the diagram. And the face has a radius of 10, with the minute hand and hour hands both having a length of 10. All right. The time shown is 6 a.m. The bottom of the clock face is located 3 centimeters above a horizontal bookshelf. So they got that on the diagram for us there. That's our situation. Make sure you understand that very clearly. Sometimes redrawing it can really help, but let's go ahead and dive in. Write down the height of the endpoint of the minute hand, so that's right here, above the bookshelf at 6 a.m. Well, all right, don't mess this one up. It's only worth 1 point, but man, every point counts. So 10 centimeters is what both the minute and hour hands distances are, plus the 3, so that's 23 centimeters. It's only 1 point, so there we go. Now, the height centimeters of the endpoint of the minute hand above the bookshelf is modeled by this function. So that's the minute hand modeled by this function right here after 6 a.m. So h of theta is equal to 10 cosine theta plus 13, where theta is the angle rotated by the minute hand after or from 6 a.m. Okay. All right, so let's see what the question is. First question right here says, find the value of h when theta is 160 degrees. Again, it's worth 2 points, so you better write it down. Yes, we're just going to plug it in, but we're going to write it down first. So 10 cosine of 160 degrees plus 13. Oops, sorry, we're going to do some calculator work here. So 3.60, rounded to 3 significant figures, and don't forget your unit. All right, so that's part G. Part H says the height G in centimeters, so G, the endpoint of the hour hand above the bookshelf is modeled by this function where theta is the angle of degrees rotated by the minute hand from 6 a.m. So the minute hand's going around, but the hour hand is moving also, and this is the function that models the height of the hour hand, the end of it above the bookshelf, and it says write down the amplitude. All right. So the amplitude is just going to be 10, right? We don't say negative 10. We just say 10 because amplitude's a distance. It's a minimum or maximum above the midline. Distance is always positive, so just write 10. All right. Now, the endpoints of the hand, of the minute hand and the hour hand, they meet at some angle, right? K. Find the smallest possible value of K. So when's the first time that they meet? Now, this is worth more than 1 point, so we're going to have to write some stuff down. Now, K is an angle, right? And where do the minute and hour hand meet after 6 o'clock? Well, that would be after 180 degrees because at 6:30, the hour hand has moved also. It's moved a little bit. So it's going to be somewhere between 6:30 and, well, definitely before 6:45 because by 6:45, the minute hand has passed the hour hand. Okay, so having that idea in our head might help us when we do our graph because that's what we're going to end up doing. We're going to end up graphing this right here, right? So here's the two pieces of information. I've put them here. They're not new. This is the function G, which is the hour hand, and this is the function H, which is the minute hand. Where do they meet after 6 o'clock? And we know it would be more than 180 degrees. So where they meet, well, you could just set the two equations equal to each other. Now let's subtract 13 from both sides, make those two things go away, and divide by 10. Just don't forget that this one's going to stay negative, right? Now on a graph, if you graph this together and you zoom into a window where x is more than 180 degrees, you can analyze the graph and find the point where they intersect. And what we're going to see is that it's equal to 196. Now, you do have to be really, really careful because the graph can be kind of hard to see on these graphing calculators. And it can look like 166, but that would actually be before 6:30. So let's fire up the document camera again and see if we can get this thing working. All right, let's see. Let's do transition. All right, here we go. All right, there's my document camera. Let me turn it on. All right, so I'm going to go home, and we're going to go to a graph right here, maybe. Okay, so let's see if I can do this. This is a little tricky, but I've got negative, I don't need 10, negative cosine. So cosine, negative cosine of, what do we have? Theta. So I'm just going to use x over 12 plus 13. So there's one graph. All right. It's going to be kind of hard to see on there. You can double tap the center to get to your other equation. So the other one we have is, oops, no, I just want that. Cosine. So we got cosine of x and then plus 13 again. So not seeing anything showing up here, but that's because I need to zoom out. I'm going to edit my window size. So we're going to do it right here. So I'm going to set the, actually I'm going to do my window settings. There we go, like that one right there. So I'm going to say x is from, well, I know it's past 180. So I'm going to go from 180, and then I'm going to do just like 270. And y, so let's see, it's plus 13. So I think I can go from 0 to 15, and then that might be good enough. Look at that. Look at that. Okay, so those are my two graphs right there. Now, I might need to zoom out a little bit. I'm not really sure, but let's see if I can just analyze the graph and find my intersection right here. So analyze graph, intersection, and let's set our lower bound. I'm going to go as far to the left as I can over here. Looks like that's it. I hope that's far enough. Oh, it wasn't. Okay, here's what I'm going to do. I got to zoom out. Oops. No, we're going to do that. Zoom out. Like that right there. Let's see. That's probably good. Okay, now let's analyze the graph again. You can see these are kind of tricky, so you definitely need to mess around with them and play with them a little bit. So let's see. We're going to say our left bound is over here somewhere, and our right bound is right there. Look at that. It's 166. Do you see that? But there's another one right there, 196. Just like we said it was, 196. Do you see? Just like we said it was right there. All right. So that's how that works. Let's go ahead and turn the document camera back off. And here we go. So pretty cool. That's that one. All right. So number 3. All right. So it says right here at the very beginning, it says give your answers in part A, D, I, E, and F to the nearest dollar. All right. So first one, Daisy's invested 37,000 Australian dollars into a fixed deposit account with an annual interest rate of 6.4 compounded quarterly. So fixed deposit account means it's not an annuity. It's like a savings account. You just put the money in there and you leave it alone and it just grows. All right. So first question is calculate the value of Daisy's investment after 2 years. Look at that. 3 points. Dang, there's 2 methods to do this one. You could use the financial solver or the interest formula. I prefer the interest formula for this kind of a question because the financial solver has some quirks that kind of vary by calculator, and this is a pretty straightforward question. I mean, I think this is actually valid for freshmen in an honors math class. So future values prior value is equal to the principal, 1 plus r over n t to the n. All right, that's our formula for compound interest. That is in your booklet, but you should know it. You should write it down every single time just like this. You get 3 points, so write down the formula. All right, so plugging in our values, I went ahead and wrote 0.064. The formula booklet actually has it divided by 100. That's just all they're doing is they're changing that percentage into a decimal, but just do it on your own. And the reason that n is 4 is because it says it's quarterly, so that's 4 times a year. And the reason the 2 is here is from the 2 years. The reason the n here, same thing, right? Quarterly. So you can just plug that into your calculator, and there you go. Now, this is part A, so it says to round to the nearest dollar, right? So you write that down anyway, and then you go ahead and round to the nearest dollar, and $42,010. That's your answer. All right, now the way you would do it on the financial solver, right, is you do the financial solver, which I'm not going to show you, but I will show you all the values that you would plug in. So these are all the numbers you'd plug in. CPY and PPY would both be 4. And I don't have on the screen the payment column or row. You would just leave that one blank. You don't even have to worry about it. So you enter all of this, and then where your cursor is, hit enter. Right? Now, when you're practicing, try both methods because you need to know both of them. You got to have them both under your hat. Okay? All right, part B. Let's see here. It says, after M months, the amount of money in the fixed deposit account has appreciated to more than 50,000 Australian dollars. So, find the minimum value of M, where M is a natural number. All right. And now this one's worth a lot. 4 points. Wow, that's a lot of points. So you better show some work. And again, you could do this one of 2 ways. I really prefer algebraically. Now, I will show you both. I'll show you how to do them both. The algebra does look kind of ugly, but it's really not that bad at all. I tried to show every single step, but after you do these just a couple times, you can put most of these steps together really quick. All right. So we wrote down our formula. We plug in our numbers. So we're trying to figure out, hey, when does it hit $50,000? After how many months? Now, the months part's kind of tricky for either one. So you got to be really careful. All right. So we're going to divide both sides by 3,700, right? 37,000. And that reduces to 50 over 37, right? Okay, so now we have to solve for the exponent, so that would be a logarithm. So logarithm or natural log, same thing. I write logarithm, natural log, because that's one less letter, and I don't know, I'm lazy. So one of the properties of logarithms is if you have an exponent, you can multiply that to the front just like this, and normally I would have skipped writing this step and done them both at the same time. And we're going to divide, right? It's kind of ugly looking, but on paper it's kind of ugly, but it's actually pretty easy. So you're going to figure out what this number is. Then you're going to divide that number by 4, right? It's harder to write than it is to do. And what you're going to find out is that t equals 4.74234 years, right? Because this is time in years. So you have to multiply that by 12 months and you get 57 months. All right, so that's kind of ugly, but it's really not that bad. You definitely need to be able to do this anyway, because a lot of the time this kind of math pops up and you got to know it. So when you practice, that's a great time without any sort of negative penalty to learn how to do something like that. Make those mistakes, learn from them, build on it. You'll be just fine. Okay, now let's dive into the financial solver method, okay? So here, the thing we don't know is n. We don't know how many times it was compounded, right? We do know the interest rate. We know the original amount. We know how much we want it to be worth. It is strange that it has to be negative. That's kind of tricky, right? The previous value has to be negative. The future value is positive. So you plug all these things in, then you put your cursor right there in N, and you hit enter. And this is the number you're going to get, 18.9692225515537. Okay, that's quarters. That's not years, because, do you see? It's compounded quarterly. So, wow, you got to divide that by 4 first, and then multiply that by 12 in order to get, in order to get the same answer. You do get the same answer either way, but do you see what I mean? Either method, you got to make sure you understand what the number means. So, either way you do it, you get the same answer, but you just got to make sure you convert your answer into months, because it says how many months. All right, next up, Buttercup. Let's see. Daisy is saving to purchase a new apartment. The price of the apartment is $200,000. She makes an initial down payment of 25% and takes out a loan to pay the rest. All right, that's her situation. Write down the amount of the loan. So if it's that much money and she takes and pays 25%, this is how much she has to borrow. She has to borrow 75%. So 75% of 200,000 is 150,000. All right. Now the loan's for 10 years. It's compounded monthly with equal payments of $1,700 made at the end of every single month. So for this loan, find, 5 points. Holy moly, that's a lot, right? First one says, find the amount of interest paid by Daisy. Well, what you're going to do is you're going to figure out how much money she actually spent. So we know that she had spent this much on payments. She made 120 payments at $1,700, and she really only borrowed that much money. So then she ended up paying $54,000 in interest, right? The reason we know that is this is how much she paid every month. She paid for that many months, and that paid back the principal plus the interest. So if we subtract the principal, all that's left is the interest. All right. So now let me show you the way to find the interest on the loan. So here, let me move it over here so we can see what we're talking about. Let's go ahead and use the financial solver. There's another way to do it. We could actually set up an equation, but let's do one example of using the financial solver to find the annual interest rate on the loan. All right, so let me move this out of the way, and let's go ahead and dive into this, right? So hit menu, right? Oh, nope, sorry. Go home. We're going to go to the calculator. All right, so there's our calculator. Hit menu and finance, number 8. Right? Financial solver. I'm just going to click enter. There's all my information. So I'm going to type in 120. I'm going to scroll down. I'm going to delete that for now because sometimes it gets a little tricky. Negative. Now, negative is this. This, not that. All right. So negative. Let's see. Can we see it again? Come on now. Okay. 150. 1, 2, 3 more. We know that the payment is $1,700 and the future value is 0. Now, the most annoying part. You can't click out of these once you click in there. So we're doing 12, but I have to use my cursor and click on another cell to get out of there. All right. And a lot of times, good. It did. It made them both 12. So now I'm going to go up to interest rate. And I click enter right there. You ready? Interest rate. Boom. 6.5779. Blah, 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 blah. Do you see how that works? Pretty cool. All right. Let's go ahead and turn the document camera back off and head back to our PowerPoint. Here we go. So plugging all those numbers in like we just showed you, put the cursor there, hit enter, and you're going to find that the interest rate after you round it was 6.46%. All right. So now, one last question about this. After paying for 5 years, she decides to pay off the remainder of the loan in one final payment. So we're going to find what that final payment would be. This is worth 3 points, so we're going to show something, right? So here's what we've got. We just entered all this into the calculator, right? And so what we're going to do is we're going to put our cursor here and then hit enter. So we have to go back to our calculator, put our cursor there, and then hit enter. All right. Now, you notice how we changed the payments from 60 to 120. The reason we did, or from 120 to 60, the reason we did that is instead of paying for 10 years, we're now paying for 5. So we put our cursor there, and then we go ahead and do it. So let's go ahead and turn the document camera back on, and I'll move it over here so it's out of the way. There we go. All right. So we're going to go, we're going to change, let's change that to 60. Number of payments is now 60. Future value, let's delete that and let's hit enter. 86972 and 61 pennies. Okay, that's pretty cool. Let's go back to our document camera here, or turn the document camera back off here. Head back to our PowerPoint. So there we go. Hit the enter. 86,973. Cool. Nearest dollar, right? Because part F, nearest dollar. So there we go. Okay, so now if you're trying to show 3 points, or get awarded points for 3 like this, you could actually write this down right here and give whoever's going to grade it evidence of what it is you were doing. Because if you maybe, I don't know, mistyped something, but you showed this, they'll actually go through and try different ways to see if they can get your same answer. Sometimes you even get full credit if you make a silly little mistake, right? All right, so now last part. Find how much money Daisy saved by making one final payment after 5 years. This is, again, worth 3 points. So here's how we're going to do that. We know that the full loan amount, we found that earlier, would be $204,000. However, if she paid it off after 5 years by paying the regular payment for 5 years, and then the last payment, this is how much she would have paid. So the difference in those is how much she saved. So $15,027. Pretty cool, right? All right, now on to part E, or part 4. Part 4, I think, is the trickiest one. We've got some calculator work and we got some stuff to figure out. Okay, so it says the stopping distance for bicycles traveling at that distance right there, 20 kilometers per hour, right? They're slowing down, though. 20 kilometers per hour are assumed to follow a normal distribution with a mean of 6.76 meters. And a standard deviation of 0.12 meters. All right. So it says, under this assumption, find, correct to 4 decimal places, the probability that a bicycle chosen at random traveling that speed manages to stop in 2 parts here, worth 3 points total, in less than 6.5 meters or more than 7 meters. Now, heads up. These answers you find here, you're going to have to use them in a new way to answer something at the end, okay? So this is definitely calculator work. This is how you're going to earn some of your credit. You're going to write down that the random variable, x, is less than 6.5, and over here you're going to write it as more than 7, of course, right? So here's how you do this. You hit Menu, probability, distributions, normal, CDF. So let me go ahead and show you that one again, okay? Might as well. We got it all set up. Let's just do it to it. Okay, so going home, let's see, let's get out of that. Go menu, right? Probability, that's number 5. Distributions, and normal, CDF. All right. So the lower bound, so less than 6.5. So that would be a lower bound of 0. And an upper bound of 6.5. Okay, cool. And then, here I've got, here, let me show you right here. And then, let's see, upper bound, lower bound, these are the numbers we're going to plug in, and that's what we're going to get. So let me go ahead and type those things in here. So we're going to type in 6.5 and 0.12, and then you hit enter. Oh, yeah, just okay. Enter. Oh, and I made some kind of silly mistake. Oh, I see what I did. All right. Menu. Probability. Distributions. Normal, CDF. So 0, 6.5, 6.76, and 0.12. So got to be careful, right? There we go. I apologize. You see right there is where I had made my mistake. So, yeah, we're going to do the same thing for the next one, right? So for the next one, let's go ahead and show you right here. For the next one, for part 2, you're going to do the same exact kind of thing. You're going to type in 7. So let's go ahead and do that. 7, probability, 5, distributions, 2. So the lower bound is 7 because we want to know more than 7. Now, how did I figure out we're going to do an upper bound of 10? Well, I was just thinking like the standard deviation is 0.12. So an outlier, man, I don't know exactly what the outliers would be, but 0.12, that's a pretty small standard deviation. So I said, well, what about 10 as an upper bound? All right, now 6.76 is our mean, and 0.12, and hit enter. And there we go, 0.2275 or 0.228, rounded to 3 significant figures. But actually, I think on this one, we're going to leave it not rounded. All right, so let me go back. Transition to get, there we go. And, all right, so this is what we got right here, 0.228, 0.228, 3 significant figures. All right, so we got those. We're going to have to come back and revisit those here in a little bit. All right, so the same information. Now it says 1,000 randomly selected bicycles are tested, and their stopping distances when traveled are at that speed are measured. Okay, so the first one, right, they're assumed. So that's expected, and now this is observed, and that's why we're going to be doing a chi-squared test. So it says find the correct to 4 significant figures, the expected number of bicycles tested that stop between here and here. It's worth 3 points, so show something, right? So first one, we're going to write down this right here. What we're going to do is just like before, we're going to type in all these numbers, and these are going to be our bounds. And then to find the expected value, we're actually going to multiply our answer by 1,000. So for the sake of quickness, we're going to just go ahead and type it out just like that. These are the values you're going to get. So just like we just did with the last example, going to type in our upper bound, lower bound, our standard deviation and mean, and write down our 2 numbers and then multiply by 1,000 because there are 1,000 bikes. So these are our expected values that we're going to get right here. Okay. Now, the measured stopping distances of those 1,000 bikes is here. Okay. So less than 6.5 was 12, between 6.5 and 7.75, or 6.75, 428, 6.75 to 7, 527. It took more than 7 meters to stop was 33 bikes out of the 1,000. Okay, so it's decided to perform a chi-squared goodness of fit test. At the 5% level of significance. To decide whether the stopping distance of the bicycles at 20 kilometers an hour can be modeled by normal distribution with a mean of 7.6 and a standard deviation of 0.12. So we made some predictions, and then we went and did some testing. So we're going to actually see if our predictions are good enough or not. So state a null and alternative hypothesis. So the null hypothesis is always that like nothing's really happening right here, right? So we can say that the stopping distances can be modeled by this right here. That's the normal distribution with, like, this is the code for it. You would write it out in words like this right here. Normal distribution of 6.76 and a standard deviation of 0.12. And the alternative hypothesis is that they cannot be. All right. So find the p-value for the test. All right. So this is where, man, we're going to do a chi-squared test. So what we need is observed and we need expected. This is observed values. And we were figuring out the expected, even though they didn't call it that earlier. In fact, in the previous two questions on part B, we found out that the expected values were here, 451.7 and 510.5 for those two right there. All right. Now, earlier, we figured out the values, the expected values for less than 6.5 and more than 7, right? Now, we found that the probability of a bike stopping in less than 6.5 meters was this. So all we got to do is multiply that by 1,000, and same for the more than 7, and that gives us these values right here, all right? So now we have to find the p-value for the test. So we're going to take our calculator, we're going to open a spreadsheet, and we're going to enter column O and E. This would be O, and this would be E, and then these are the steps we're going to follow, right? I'm going to select our columns, hit enter. Now, one thing you got to know is the degree of freedom. Well, that's the number of categories minus 1. So we have 1, 2, 3, 4 categories. So degree of freedom is 3. So why don't you go ahead and try that on your calculator? And this is what you're going to get right here. 0.0727. Okay, so why don't you go ahead and try that there? That's the p-value that you're going to find. All right, now, finishing up this question, it says state the conclusion of the test, give your reason. All right, well, because that is a little bit more than 0.05, that's our threshold, that's not enough information to reject the null hypothesis. All right, so now let's dive into the last one, the calculus. So we've got this graph right here, and it says a cross-sectional view of a tunnel. It's kind of a weird shape looking thing, right? Anyway, a cross-sectional view of a tunnel is shown on the axes below. The line AB represents the vertical wall, AB, so that's the wall. Located on the left side of the tunnel, the height measured in meters, they don't know how to spell in England, that's so sad, of the tunnel above the horizontal ground is modeled by this function right here. Y equals negative 0.01x cubed plus 0.8x squared, for x being between 2 and 8 relative to an origin O. And it says point A has the coordinates of 2, 0, point B is 2. Oh, look at that, 2 and 2.4, and point C has the coordinates of 8, 0. So that's 2.4 right there. That's interesting. The reason I say that's interesting is because I didn't see that earlier. All right, no big deal. Question A, find the derivative dy dx and then find the maximum height of the tunnel. Well, this is where 6 points, that's a ton of points. So let's go ahead and get every single one of those points. Let's get greedy. Here's our function. Right here, we take its derivative, it's the power rule, so we multiply by 3. So negative 0.1 times 3 is negative 0.3, and then subtract 1 from the exponent to give us 2. And then here we multiply 0.8 times 2 is 1.6. Subtract 1 from the exponent, you get 1. So just the power rule, no big deal on that one at all, right? All right, so now the second part, finding the height, well, we're going to set that equal to 0. Right, because this is the derivative is the slope, so we're looking for where the slope is 0. So we set it equal to 0. We can factor it. We can factor out an x, and so either this equals 0 or this equals 0. Well, it doesn't make any sense that x would be 0 because that's not a maximum height. So let's forget about that, and let's set this equal to 0 and solve it. just subtract 1.6 from both sides. That's how we get it over here. And then divide by negative 0.3. And plug that into our calculator. And we find out that when x, this is x, is 5.33 meters, then we know that that's where the height is at its maximum. So that's somewhere over here. But that's not the height. So to find the height, we have to plug it into the original equation. And we just do it like that. And we find that it's at 7.59 meters. Pretty cool, pretty cool. All right, now part B. Use the trapezoid rule with 3 intervals. And this is where I didn't recognize that they gave us the value of point B. But that's okay. Man, even though I'm harping on reading, man, I guess I'm a hypocrite. It's really easy to mess these things up. It's got to take your time, all right? So this is worth 3 points. Let's see here. It says when x equals 4, the height of the tunnel is 6.4. So it gives us that point right there. When it's 6, it's 7.2. So that's pretty cool right there. And that's point D and point E. All right, so let's go ahead and put that information on the graph. Let's go ahead and write down our formula, right? Actually, even though this is 3 points and the other one was 6, I actually think this is a little trickier to do. All right, so this is our formula right from the book. H is B minus A over N. Well, N is the number of intervals, right? And there are 3 of them. And the B and A, those are the endpoints. So B is 8, A is 2. So 8 minus 2 is 6. N is 3. So H is equal to 2. Now, plugging that in right here, 1/2 of H, well, of course, that's going to be 1. So this whole thing is just 1. All right. Now, let's see what else we know. Y0 and Yn. So we know that point is 8, 0. So I know that the Y for the very last one is 0. All right. The Y for the very first one, well, I didn't see that it had given us that 0.2, 2.4. So I actually plugged 2 into this and found out it was 2.4 anyway. So I know that Y sub 0, Y naught, is 2.4. All right, so now Y1 is 6.4, Y2 is 7.2. Those are these, and that's it. That's all the points we need. So we're approximately plugging that into our calculator, 29.6 square meters. That's pretty cool. All right. All right, so now this next part, it says write down the integral that you're going to use to find the cross-section of the tunnel, and then hence, find the cross-sectional area of the tunnel. Well, that's worth 4 points, so we're going to show some work. This is the integral you're going to use, right? And then you're going to plug that into the calculator. So for the very last time in this very long review video, let's go ahead and turn our calculator back on. Let's see here. Document camera. Let me turn that on. All right, here we go. Should see it now. It's booting up. Let me click OK. All right. So now, check this out. This integral we can enter. It's this button right over here. Do you see it? That button right there. I'm going to click it. Okay, I'm going to click it. Now, do you see the display? I got all of these options right here. And look at that one right there. Might be kind of hard to see, but I'm just going to hit enter. And look what I get. So now I can type in all of my numbers. So from 2 to 8. All right, so negative 0.1. Now I use negative, not minus, right? So negative 0.1, negative 0.1, x to the power of 3. All right, plus 0.8 x squared. And that's it for that. And then I go over here and I hit dx and hit enter. 32.4. Well, how fancy is that? 32.4. Pretty cool. So there we go. That about wraps it up. That is the end of all of our stuff for this entire test. Man, it's been a journey. It's been a long video. A lot of stuff going on here, a lot of stuff to learn. But I do believe these are very approachable tests. There's a lot of stuff to study, but if you start doing it ahead of time, refresh and practice and practice and refresh, set a schedule, man, you can get a 7 on these tests. Hey, until next time, I hope you have a great day.